Did it start? Yes, it did. Okay, 8.2.3. What happens if the exponent is negative? I did not bring my notes with me, so I'm going to be doing this on the fly. Okay, so earlier we learned about how to write large numbers in scientific notation, and we know astronomers use those large numbers to measure the big distances in space. But not all scientists work with such a large scale. Some scientists use very small numbers to describe what they measure under a microscope, like cells. In this lesson, you'll continue your work with exponents, and then you'll turn your attention to using scientific notation to represent small numbers. So we have quite a bit of problems to get through today, so we're going to get started now. 8-72. So 8-72 is A through F. It says 2 of these problems below are correct and 4 contain errors. Expand each original expression to verify that it is correct. If it's not, identify the mistake and simplify to find the correct answer. So I'm looking at this part A, and it says x to the third, y to the second, x to the fourth equals x to the seventh, y to the second. Yeah. All right, so it wants us to expand each original expression. So let's see if this matches this. So I'm going to expand that out to x times x times x. That's going to expand to y times y. That's going to expand to x times x times x times x. So I'm looking and I'm counting my x's, 1, 2, 3, 4, 5, 6, 7. That works. And then y is just 2 y's. So I have x to the 7th, y to the 2nd. So A looks correct to me. Part B is 2 cubed times 2 to the 4th equals 2 to the 12th. This one's looking a little wonky to me. Let's make sure it's correct or not. 2 times 2 times 2 is this one, and then we're going to multiply it by 2 times 2 times 2 times 2. Count them up, 1, 2, 3, 4, 5, 6, 7. So no, this is not correct. This should say, sorry, I'm not going to put an X, I'll put incorrect. Should be 2 to the 7th, because when you are multiplying the same bases together, you just add the exponents. Looks like they multiplied the exponents. Incorrect. Part C. I gotta make this bigger because I can't even see it. Okay, 7 to the 2nd times 8 to the 3rd divided by 7 to the 3rd times 8 to the 2nd comes out to 8 to the 7th. This is one we haven't worked on a lot, so let's look at this division stuff. First, let's expand the top, and then we're going to expand the bottom. So let's do the top first. 7 times 7. Then we have 8 times 8 times 8. Divided by 7 times 7 times 7 times 8 times 8. Oops. So I'm looking for some 1s here. So I know that a 7 divided by a 7 gives me 1. So I can get rid of that. Another 7 divided by 7 gives me 1. I'm out of 7, so that 7 stays there. Then 8 divided by 8 gives me 1. 8 divided by 8 gives me 1. I'm only left with the top is 8 and the bottom 7. So that one looks correct to me. So it says 2 are correct and 4 contain errors. So I'm going to assume that the rest are going to contain errors. Since we have 2 correct so far. So the next one is D. 3 to the 5th times 3 to the 2nd equals 9 to the 7th. Okay, let's expand it out. 3 times 3 times 3 times 3 times 3. That's 3 to the 5th. 3 times 3 is 3 to the 2nd. 1, 2, 3, 4, 5, 6, 7. So that's incorrect. That's not 9 to the 7th. 3 to the 7th. I think they multiplied the 3's together to get that 9. That's incorrect. You can't do that. I mean, you could, but whatever. 6 to the 2nd over 6 to the 5th equals 6 to the 3rd. All right, let's let's expand out the fractions. We have 6 times 6 on top. Then we have 6 times 6 times 6 times 6 times 6 on the bottom. So I have some simplifying to do. I'm going to look for my ones. 6 divided by 6 gives me 1. Cross that out. 6 divided by 6 gives me another 1. Cross that out. So I'm left with, and I can't do anything else because there's nothing left on top. That just means 1. 1 over 6 3 times, so 6 to the third. So that one's incorrect. It should be 1 over 6 to the third, not 6 to the third. Okay. Incorrect. And that means that that's correct. F is z to the third and z to the third. And I'm putting the line in the z so it doesn't look like a 2 equals 0. So let's simplify this out. I'm going to do it over here this time. So z times z times z over z times z times z. Z divided by z is 1, 1, 1. So we are left with 1, not 0. So that's incorrect. It needs to be a 1. Whoa, incorrect. And it works out because we knew that the last 3 had to be incorrect. All right, moving on to 873. Rewrite each expression in a simpler form using the patterns you have found for rewriting expressions with exponents. If it's reasonable, write out the factored form to help you. 2 to the third times 2 to the fourth is a. So we know that if we multiply the same bases, we add the exponents and we keep the base the same. So 2 to the 7th would be our first one. B, 2 to the 8th over 2 to the 5th. Well, looking at the previous problems, I noticed that when you're dividing by the same base, you subtract the exponents. So 8 minus 5 would be 2 to the third, and if you factored it out, you'd notice that you would cross out all those ones, and you'd be left with 2 to the third on top. Right? Because all those would be gone on the bottom. You'd be left with 3 2's on the top. So look at this one, 5x squared, parentheses, to the third power. Okay, now everything inside, which you should have saw in the last lesson, when there's parentheses, everything inside has to be attached to the exponent. The exponent affects everything inside. So 5 times 5 times 5, 5 to the third, x squared times x squared times x squared. So that would be 5 to the third, x to the 6th. And also you'll see that we can multiply the exponent when we have exponent being raised to an exponent. So 5 to the third, x to the 6th. Let's do D. D is 4x parentheses squared, and then 5x is 5x squared. So this one, same idea, distribute that exponent to everything in the parentheses. This one doesn't, because it doesn't have anything on the outside. So let's see, 4 times 4 times x, and then times 5x squared. So now I can do, let's see, 4 squared times 5 times x squared, x to the third, x to the fourth. Double check that one. I think it's correct. Yep. And if you wanted to simplify it even further, you could do 4 to the second power, which is 16 times 5, which is 80, sorry. 80x to the fourth. If you wanted to simplify it even further. Okay, moving on. The next problem is the learning log. I'm not going to make you do it because I think we've discussed how to simplify exponents enough. Let me see. Let me see what the learning log says. Come on. The learning log says simplifying exponent expressions. I think we're good on that. So let's move to 875. Whoa, I'm writing too many parentheses. Okay, Salvador was studying microscopic pond animals in science class. He read that amoebas were 0.3 millimeters to 0.6 millimeters in length. He saw that euglenas are as small as 8 times 10 to the negative 2 millimeters, but he did not know how big or small of a measurement that was. He decided to figure out what a negative exponent could mean. So now it says to copy and complete his calculations at the right. Use the pattern of dividing by 10 to fill in the missing values. So we're going to write down his pattern, which is in the book. And it starts with 10 to the third equals 1,000. Divide that by 10, and you get 10 to the second equals 100. Divide that by 10, get 10 to the first equals 10. Then it says divide by 10. So now it's giving us 10 to the 0. So if I divided 10 divided by 10, I get 1. So 10 to the 0 equals 1. Divide that by 10. So 10 to the negative 1 would be 1 divided by 10, which is just 1 over 10. Let's divide that by 10. 10 to the negative second would be, if you do 1/10 divided by 10, you get 1 over 100. Divide that by 10, you get 10 to the negative third, which is 1 over 1,000. So there's a nice pattern happening. Part B says, how does 10 to the second relate to 10 to the negative second power? Well, 10 to the second is 100, and 10 to the negative second is the inverse, or the flipped version of 100. It's 1 over 100. It's a fraction. C, what type of numbers did the negative exponents create? They created fractions. Did negative exponents create negative numbers? No. I don't see any negative numbers here, so no. Do not assume that just because an exponent is negative that it's a negative number. It is a fraction. It creates fractions. All right, so 876. I can't pronounce this name. Ngok was curious about what Salvador was doing and began exploring patterns too. He completed the calculations at right. So now we're going to do the same thing, but with his calculations. So we're going to write down, be sure to include all, yeah, okay. 2 to the 5th equals 32. 2 to the 4th equals 16. 2 to the 3rd equals 8. 2 to the 2nd equals, we don't know yet, 2 to the 1st, 2 to the 0, 2 to the negative 1 is 1/2, 2 to the negative 2, and then 2 to the negative 3. It wants us to do all of those. And it wants us to look for the patterns. Okay, so for every exponent you go down by 1, it looks like you're dividing this in half. Right? 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So now we've got 1/2 here because we know that we have a negative exponent. So that flips the number upside down. So now 2 to the negative second, I'm going to assume is 1 to the 4th. And then 2 to the negative 3 would be 1 to the 8th. It says, how are the values to the right of the equal sign changing? Well, you're dividing by 2. Every single time, we're dividing by 2. Is there a constant multiplier? Yes, it's 2. All right, let's look at 877. In problem 875 and 876, you saw that 10 to the 0 and 2 to the 0 power both simplified to the same value. What is it? It was 1. They were both 1. Do you think any number to the 0 power would have the same answer? And I'm going to say that yes, any number to the 0 power would equal 1, because you're basically dividing the number by itself, as you saw in the patterns that we did. Make sure this is recording. Okay, good. So yes, even like 1,000 to the 0 power would be 1. 2,000 to the 0 power would be 1. No matter what number to the 0 power, it's going to be 1. All right, 878. Almost done. Both Nagak, I can't say that, and Salvador are looking for ways to calculate values with negative exponents without extending a pattern. Looking at the expression 5 to the negative second power, they each started to simplify differently. Salvador thinks 5 to the second, so Sal thinks 5 to the second is 25. So 5 to the negative second must be 1 over 25. His friend said 5 to the negative second is 1 over 5 to the second. Who is correct? So it looks like they're both correct. 5 to the second is 5 times 5, 25. So that's right. 5 to the negative second would just be 5 times 5 flipped on its head, 1 over 25. And that's just the same, but he just didn't simplify it all the way. So they are both correct. 5 to the negative second could either be written as 1 over 5 to the second or 1 over 25. Okay, we are in the last problem, 879. Salvador's first questions about negative exponents came from science class, where you learned that Euglina's measured 8.0 times 10 to the negative 2 millimeters. Use your understanding of negative exponents to rewrite 8.0 times 10 to the negative second in standard form. So we're going to write 8.0 out with its standard form applied, or its scientific notation applied. So remember scientific notation. Remember, if we had 8 times 10 to the second, we would move the decimal over to the right twice, and we would get like 800. So it made the number bigger. Now we're doing it in reverse, because we have a negative exponent. We're making the number smaller, right? Because every time you have a negative exponent, that number becomes a fraction, so it becomes smaller. So 8.0, we're going to move the decimal to the left now, because it's a negative exponent. 1, 2. So I'm left with 0.08 millimeters, right? That's very, very, very small. 0.08 of a millimeter. All right, and that, I believe, concludes 8.2.3. See ya in the next one. Bye.